Hey you guys, we're back. This is the second part of the section 9.2 videos on compound inequalities. If you have not watched the first part of 9.2, stop this video, go back, watch that one first, and then come back and check this one out. So we just left off, we were talking about compound inequalities and how they were related to the word and. When we started off, we were looking at some sets, and I was showing you how using the intersection symbol was similar to using the word and. Well, we're going to start off in that same sort of thread, and what we're going to do is I'm going to show you how using sets is going to take us through these compound inequalities with the word or this time. So this part of our notes is going to deal with compound inequalities using the word or. And I think what you'll find is that this one's going to be a little bit easier to work with. And when we did that word, the word and, that is, in the first video, that was pretty restrictive because it was looking at what did things have in common. And only things that were in common or where graphs overlapped, that was the only thing that we would take into consideration for our solution. When we're dealing with the word or, everything gets to be a part of the solution. If it works for one of the inequalities, if it works for one of the sets, it's going to be part of our solution. So to start off with, I want to just kind of do that work with the sets first. And the symbol that we're going to be using now is one that you guys have seen in class before, but we haven't gone into any great detail. It's the big capital U there. And this is the symbol for the word union. And the union is very much like the word or. And the union doesn't care what is in your different sets. The union will just take everything, right? There are zero restrictions here. So kind of like what we did before, let's just look at this in terms of a couple of different sets. So if I started us off by taking set A, and suppose that set A was the numbers 1, 4, and 7. And then maybe we have another set B, and in set B we have the numbers, I don't know, 2, 3, and 6. If I had asked you to find the intersection of these two sets, you would have told me it's the empty set because they have nothing in common, and you'd be absolutely right. But if I ask you instead to find the union of the two sets, then what I'm asking you for is essentially to write down everything that's represented in both of the sets. Now, you could put these items in any order. We don't really worry about order when they're listed out, but generally you'll see them in numerical order or potentially alphabetical order as the case may be. So if I was writing down my solution, I would write it as the numbers 1, 2, 3, 4, 6, 7. All right, that would be our solution. Okay, so it's everything from both sets. So the one thing that you're not going to see when you guys are working through these problems in your syllabus is that you're not going to see the empty set show up when you're doing a union. All right, that's not going to happen. So let's try another one. Let's say we have set A is, I don't know, let's suppose set A is the number, let's do letters this time. How about that? Let's do ABC. I think we did this one in the last video. We'll do set B. That can be XYZ. So again, when we did the intersection, the symbol with the upside down U, that intersection had an empty set as its solution because there were no elements of each set that were in common. Now, we don't care about that anymore. All we want to do is just write everything down. So if we were asked to find the union of these two sets, it would be the set A, B, C, X, Y, Z, just like that. And there would be everything. Now, it is possible that you could have some scenarios where you're asked to maybe look at both union and intersection with these sets in the same type of problem. So let me just run through one of those real quick. That way you've seen it in case you encounter any. Let's take set A to be the numbers 1, 2, 3, and 4. And set B can be the set of numbers 5, 6, and 7. And set C, let's make that the set containing the number 8. So here's one thing that you might be asked to do. Actually, let me, before I do this, because otherwise this example is going to be kind of lame, let me modify set B just a little bit if I could. I want to add on the number 8 to that set. I want it to be 5, 6, 7, 8. There we go. This will work better this way. So let's say that we're asked to find, let's find A, set A, and the union with what? Well, let's union this up with the intersection of B and C. So you may see something like this. So what this is telling you to do is first do the parenthesis portion to start, and that would be to find the intersection of sets B and C. So I have to do this first because of the parentheses. So what would be the intersection of B and C? Well, if you remember from the last video that the intersection is, well, what do they have in common? And here, what they have in common is the number 8. So what this is asking us to do is essentially find set A, and we're going to find the union of that with this set 8, which is the intersection of B and C. Maybe let me write that over here off to the side. B intersected with C is the set containing the number 8. Okay, so what would I get if I was trying to find set A and the union of that with the set containing the number 8? Well, remember set A was the numbers 1, 2, 3, and 4. So we could write this out as the set 1, 2, 3, 4. And we want to take the union of that with set containing 8. And remember, the union is not restrictive. The union just says, hey, if it's there, take it. It's part of the answer. And so all I got to do is write down everything I see. 1, 2, 3, 4, and 8. And that answers the question. All right, so if you have something like that where you're dealing with multiple sets, like more than 2, just do the parenthesis work first, and then just take that answer and carry it through with the rest of the problem, and I think you'll be okay. All right, if there's questions on that, you guys know the routine. Come to my Zoom office hour meeting and we can chat about it. All right, so let's do some inequalities using the word or. And we'll just kind of pick up where we left off from before. And again, numbering wise, I'm numbering them to match the notes. That way, if you guys have an example question, instead of saying, you know, to me in an email or something, you know, the one example where you did this, like just tell me, hey, example 6, I didn't get this part of it. So example 6 is where we are now. And in example 6, here's what we've got. We have 2x minus 3 is less than 7. The word connecting is or. On the other side of this, we have 35, take away 4x, and this is less than or equal to positive 3. So the beginning parts of these problems, it doesn't matter the word in between for how you're going to start them. Again, the word in between this one is or. We have to solve each of the inequalities regardless. So if I want to solve the inequality on the left, I'm going to add 3 on both sides. And I get 2x less than 10. and then divide both sides by 2, and we get x is less than 5. So again, we're not going to do anything with that, right? We're not going to put a box around that right now. This is not our solution. We're just going to kind of put a pin in that, and then we're going to go to the other side and solve the other inequality. Now, if you remember from 9.1, what I like to do when I'm solving these inequalities is keep my variable on the left, because I prefer that for graphing down the road. So on both sides, I'm going to start by subtracting 35. And I get negative 4x is less than or equal to negative 32. And then I have to divide both sides by negative 4. Now this should set up a bit of a red flag for you, because we're doing an inequality and we're dividing both sides by a negative number. So remember, when you do that, you have to switch the inequality symbol around. So cancel the negative 4's, and we're going to get x is, it's now greater than or equal to, and negative 32 divided by negative 4 becomes positive 8. Okay, so we've solved each one. Now we're going to do exactly what we did before. We're going to go to the number line and we're going to generate a graph so we can kind of see what we're dealing with here. I think on these, having a little visual can really help in understanding what's going on. So I will use different colors again. So on this first inequality, it says x is less than 5. So I'll put 5 on my number line. Because it's just less than, I'm going to put the open circle. And because of the way my inequality symbol is pointing, because I left x on the left-hand side for this little shortcut purpose, my graph goes to the left, like so. And then if we graph our other inequality, x is greater than or equal to 8, let's put 8 over here. This time we're going to get a closed circle, and our line is going to head off to the right. Well, if you saw a graph like this, and the word connecting them was and, what would your answer be? Think about that for just a second. If the word connecting these inequalities was and this was the graph that you found, your solution would be the empty set, right? Or you would maybe write down no solution, because there is no overlap. But that's not what we're dealing with here. Here we have the word or, and we're just going to take everything. If it's part of the graph, if it's on the graph, I'm going to take it as part of my solution. So the way that we're going to generate our solution is to just look at the graph. Now, we had a little practice in this back in the last chapter, where we were looking at graphs like these and trying to write down what was the interval notation for the graph. So we always write down our answer from left to right. So looking at the far left of this graph, I'm talking about the green part of it right now, how far out to the left does that graph go? And you would answer negative infinity. So we would put negative infinity. Of course, remember, anytime we're doing an infinite value, we always put the parentheses on it. And this is negative infinity all the way up until we reach the number 5. Now the question is, on 5, would we put that with a parenthesis or a bracket? And hopefully you'd be able to tell, because of the open circle, there would be a parenthesis there. Not like that though. Like, stupid technology. There we go. Okay. Now that's not the whole thing though, because that part of our solution, that only accounts for the green part of the graph. I still need to include the blue part as well. So because I'm going to have a separate interval that I'm going to be attaching here, the way you attach another interval is with that union symbol that we talked about earlier. So go ahead and put that union symbol there. And then this graph, the blue graph, it kind of picks up again at 8. Now at 8, when we have a parenthesis or a bracket, and because of the closed circle, that's going to tell us there's a bracket there. And then the blue graph heads on all the way out towards infinity. And there is our solution. Okay, so again, this is what I'm getting at when I tell you guys to please pay careful attention to the word that's in between them. Because if I gave the same problem with the word and, you'd have no solution. By giving it with the word or, we've got an answer, and a kind of an involved answer at that. Okay, I hope that one makes sense for you. I want to do one more for the or inequalities, and then that will wrap up this section. So this is example 7. And on this example, it says to solve, and we're solving 3x minus 5 is less than or equal to 13, or 5x plus 2 is greater than negative 3. All right, so I'm paying careful attention. I'm being a good student. I know the word in between is or, so I know when I get to the end of this thing, I'm looking for everything, right? No restrictions on my solution. Okay, so let's solve the inequality that is on the left. We'll start by adding 5 on both sides. We get 3x is less than or equal to 18. And then divide both sides by 3, and you get x less than or equal to 6. Okay, we've done enough of these now. I hope that you know to just kind of leave that thing alone for right now. And let's go to the other side and solve our other inequality. So first step is to subtract 2 on both sides. We get 5x is greater than negative 5. And then we want to divide both sides by 5. Now, quick question for you. If I'm dividing both sides by 5 right here, because I have the negative 5 on the right, do I switch the inequality symbol around? I really hope you just said no, because that's the correct answer. You don't switch the inequality symbol around because we're dividing both sides by positive 5. So we get x is greater than negative 1. Okay, so we have them both solved. Let's go to the graph to make our number line graph. So this first one, it says x is less than or equal to 6. So on my graph, let me put 6. Let's suppose 6 is right here. This would get a closed circle because of the less than or equal to. And this is going off to the left. So our graph would look something like this. All right, let's look at the other graph. We'll graph this one in blue. This says x is greater than negative 1. So negative 1 maybe is, I don't know, we'll put it right here. Now negative 1 is going to get an open circle, like so. And let's go ahead and send the line off to the right, because that's the correct thing to do. And we want to know what is our solution. So remember, we're not looking for an overlap when it comes to the word or. All we care about is as long as one of the graphs has that number on the number line as part of its solution, then it's going to be part of our solution for the entire compound inequality. So all we got to do is just look left to right as we did before. So here's our solution. Either graph, green or blue, how far to the left does one of them go? The farthest to the left that we can go is with the green graph, and that's taken off all the way to minus infinity. So we know for sure our answers are heading out towards negative infinity. And you can see from the blue graph that the answers are headed out towards positive infinity, and that there are no breaks, right? There's nowhere on either of these two graphs where we don't have a value. Now, the one spot that everybody's probably thinking about right now is this spot right here. And you guys are probably thinking to yourself, wait a minute, there's an open circle there. That number doesn't count. Well, it doesn't count on the blue graph, but remember that if you see a line, that's just like a closed circle, and it does count on the green graph. So as long as it's there for one of the two graphs, then we're okay. So this solution runs from negative infinity to positive infinity, or you could just simply write down all real numbers. Now, before I conclude this one, I want to just do one quick little sort of add-on to the example that we just did. I want to say, what if, we do these sometimes in class, right? What if this one had the word and instead of the word or? What would be the solution there? So if the word connecting, it was the exact same problem, the only difference is the word connecting would be and instead of or. Well, in that scenario, we would be looking for the overlap with and. So I'm looking for where do these two graphs overlap each other? Well, it's going to be from right here to right here, and it would be all of these numbers on the number line that kind of fit in that space. So that would be all the numbers from, can you figure it out? What would be the solution in that case? So it would be all the numbers from -1 up to 6. Okay, now the question is, would we put not open or closed circles, would we put parentheses or brackets? So looking at the -1, remember with and, the number has to be there on both graphs. So at -1, yeah, it works on the green graph, but it doesn't work on the blue graph. So because it's not a part of both graphs, we have to put the parenthesis. If you look at the 6 does work, right? Because when you see the line, it's the same as seeing a closed circle. We have that point on both of our graphs, and because it's on both, we can include it, and we would put the bracket. Okay, so if that word had been and, this would be your answer. But ours was or, and so the answer was all real numbers. Okay, that wraps up section 9.2. Again, if you guys have questions on any of this stuff, please reach out to me. Make sure you're practicing the problems in the syllabus. And that's it until next time. All right, you guys.